Hello, so in this lesson I wanted to look at integration, so reversing that process of differentiation, and I wanted to look at it for specific functions that you'll be familiar with hopefully by now. This is from the textbook page 294 and it gives you a synopsis of all of the main functions that you'll be asked to integrate potentially at some point during the course. What I've also done is I'm going to include a picture of the formula booklet so that you can see which equations you're given as part of the formula booklet, so that you know which bits you need to learn and which bits you can just sort of look to your book and get those from there and not spend a great deal of time worrying over those. So if we match them up, so we can see that sine x is given to us here, okay, but it is not in the formula booklet, so this is one that you need to learn. Similarly with cosine of x, they are not given to you here in the formula booklet, so that's also one that you need to learn off by heart. If we have a look at sec squared x, I'll put that in green because sec squared x is given to you in the exam booklet, so we don't need to worry too much about learning that one off by heart. You've got cosec x, cot x. You'll see that that is not in your formula booklet, so that's another one that you will need to learn the just learn the answer to that one there. Cosec squared x, again, is not in your formula booklet, which is one that you will therefore need to learn. And finally, sec x tan x, that is not one that's in your formula booklet, so that's also one that you will need to learn. You'll see the functions at the top. The first one is just the standard integration, so if you see here, increase the power by 1, divide by the new power, so that's just the standard integration sort of formula essentially. Ln of x, we've had a look at that because we've done some work on partial fractions, and then e of x there, we know that one of the special features of e of x is that gradient function is exactly the same as the function, and so when we integrate, because it wasn't really changed to start with, there's not much to worry about there. The only thing we will need to consider is if there is a coefficient of x on the go. Right, so let's start to think about these ones that we need to learn. Okay, so with the sine x and cosine x, just want to remind you of what we did when we looked at differentiating those. So if we set ourselves up with an axis, almost like the xy axis, we know that if I put sine here and cosine of x here, then this would be the negative part of the axes, so minus sine of x. I should really put brackets around these. Okay, and then if this is the positive axis for cosine of x, then this is the negative part of the axis here for cosine of x. So when we were differentiating, we went in a clockwise direction, so we know that sine of x differentiates to give us cosine of x, cosine of x differentiates to give us minus sine of x, minus sine differentiates to minus cosine, and minus cosine therefore goes back to sine of x. That was, as I say, if we were differentiating those functions. So this is a very useful tool because it can also go backwards and we can use it for our integration. So if I was, for example, integrating sine of x, that would go to minus cosine of x. Integrating this function would take me around to this side, and you could just sort of keep working your way around there. So anything involving sine and cosine x, it'd be well worth your time investing in just sketching this out quickly and reminding yourself clockwise is differentiating and anti-clockwise is integrating. And that'll just help you avoid any of those slips in terms of your negatives, which are popular questions, as you can imagine, because people miss those out. Okay, so these are the ones that are not in your formula booklet under integration. However, rather than having to spend an awful amount of time learning what these are, you just need to be clever in terms of knowing where to look for them. So if I consider that integrating cosec x cot x gives me this function here, the cosec x, consider it in reverse. That means that cosec x, if differentiated, will give you cosec x cot x, which brings me to a clever little trick. If you, are worried about learning these or not sure you're going to get the answers or have the time, etc., then take a look at the previous page in your formula booklet under derivative, where the differentiation questions are, and you will notice that all of those functions there that I've just discussed are listed as derivatives. So if we've got a function sec x, if we differentiate that, we can see here that that gives us sec x tan x. And that way, you don't need to learn the integration, which is just the reverse process. So you now know that integrating sec of x tan x with respect to x is going to give us sec x again. So you technically don't need to learn any of those formulas, you just need to know where to look for them. Okay, so here is an example that we are going to have a look at. This is how questions would be written, and I just want to draw your attention to one thing, really. So the function has been put into brackets. That doesn't mean anything, and you don't need to worry about that. Sometimes people worry that that might mean the bracket is squared, or that there's something special going on here. Really, the only reason that the question has been put into brackets is just that all of it is being integrated with respect to x. So they demonstrate that by putting it into brackets. The dx goes at the end to show you that with respect to x applies to everything there that has been written beforehand, not just one specific part. So the brackets, really, if they start to cause an issue, please don't worry about it. Imagine that they're not there. And if you would like to, you can work with it written out in this way. So let's have a look at integrating it then. Cosine of x is that first one that we came up against. So cosine of x, if we draw our little arrows there, or our axes, and that's sine, cosine, minus cosine. So if I want to integrate, I'm going anti-clockwise. So cosine goes to sine. So part of my answer there, the 2 in front is just a coefficient, so 2 times by sine of x. We've done some work with this next part when we've been doing partial fractions, so I hope you realise that this is the same as having 3 times by 1 over x, and we know that this 1 over x function here becomes the log. So I've got plus 3, which again is just a coefficient the same way as the 2, ln of x. We'll put a modulus in there so that we know we're not putting any negative numbers should we look to evaluate an integral that has got limits. So that's just standard practice to make sure you write sort of modular signs either side of your x to show that we're not substituting into it negative numbers. Because just going on a tangent, if you remember the log function, we cannot substitute in values below 0 and including 0 from the x-axis, which is why we always sort of say a modulus to keep those numbers positive. Finally, the minus the square root of x. You remember, hopefully, that whenever we're working with functions like that, what we need to do first of all is rewrite them with a power. So the square root of x, you hopefully remember, is x to the power of a half. And then I just apply the formula for integration. So increase the power by 1 and divide by the new power. Of course, remembering that if I have x to the power of 3 over 2 divided by 3 over 2, it's the same as having x to the power of 3 over 2 multiplied by 2 over 3. So that's going to give me 2x to the power of 3 over 2 all divided by 3. And then, don't be a heathen, remember to put that plus c on the end. There are marks specifically for that wonderful plus c in your exam. And there is our answer, all done and dusted. Okay, so here we have another example that we're just going to work through. This will be our final one for this session. Here's a question that involves cosine x over sine squared x. So you might be asked to integrate something like this, and you might then start to look through your formula booklet just to remind yourself of the different functions and what they integrate to give. It's quite tricky really knowing what to do here. The added difficulty is this squared on my sine of x there. If it was cosine x over sine x, you know that would be the same as 1 over tan x, so we could use cot x and you could start looking through for something like that. But having that squared, is really going to make this first one a little bit more of a puzzle to work through. So I'm going to start considering the different values. So I know we're not really going to be using this one because I've got the sin x there in my denominator. I know I'm not really going to be using this one because I've got the cosine x in the numerator. Sec squared x, okay, so sec squared x, we know that's 1 over cosine. That again is just working with one trig function, which is the cosine function. And I know that my question again involves this sin x there. So I don't really think I'm going to have anything to do with that. Then going to have a look at the next one, so cosec x cot x. So that's something that involves a sine, and then the cot we know involves a tan. Okay, so having a look at this, that could potentially be something that we work with. The next one is cosec x, which we know is 1 over sine squared x. Again, we have got a sine squared x, and it is 1 over sine squared x. So maybe that would be something else that we considered working with. And then finally here, we've got sec x tan x. And again, sec x being 1 over cosine x. We don't have a 1 over cosine of x. Cosine x is in the numerator here. So I don't think we'll have that to do, but who knows? I'm going to scribble it out and just sort of look at these first two here that we've got. So this is how you would attempt this question. You know, it's going through a process of elimination, trying to see which of those, standard results you have would fit this question. So I'm going to split it up. So cosine of x over sine squared of x could be rewritten as cosine of x times by 1 over sine squared of x. And that would give me cosine of x times by, so 1 over sine squared of x, we know that that can be rewritten as cosec squared x. So all in all, cosec squared of x cos x. No, that isn't really giving me any of these values here just yet, is it? Okay, so try something different. So this time I'm going to split it up as follows. I'm going to split it up as cosine of x. I'm going to take that denominator, I'm going to split it into two parts. So sine of x times by another fraction over sine of x. Cosine x is all I've got in my numerator, so I've just got that 1 there. Okay, so this is another way we could play around with it. Cosine x over sine of x. So I know that sine x over cosine of x is tan x. So this value of cosine x over sine x is going to give me cot x. There. And then 1 over sine x can be written as cosec x. Does that match up to something I have? Haha, yes it does. So I'm going to use that now and use that, replace that in my original integral and have it as part of one of these standard results, specifically this one. So using that standard result, I see that cot x cosec x, when integrated, becomes minus, excuse me, why have I got an integral sign in my answer? Don't need that. So cot x cosec x becomes minus cosec x. And remember, this is one of the ones that you'll be looking for in the differential part of your formula booklet. Minus, so that 2 times by e to the x, that 2 is just a coefficient, so we're keeping that. And we know that e to the x doesn't change when it's differentiated. It's not going to change when integrated unless there is a number in front of the x. So that just becomes 2 times e to the x. And then, never, ever, ever forgetting, plus c. Lovely. Thank you very much. Okay, so just a little annotation. Looking back on this, I realised that I made a little bit of a mistake here. So first thing I want to just say is that I should have got a dx there, okay, to show that I'm still integrating that with respect to x, and that I didn't actually, after doing all of this work here, didn't actually write the question out in full, so I've just finished that off there. Okay, so just looking back, I realised that I missed a couple of bits out on this exercise. So I just want to show you that I've put with respect to x here when I just took those brackets away. And also, after doing the work on this part here, I didn't actually rewrite the question simplified. So I have done it there. Thank you.